Welcome to Chapter 12. This is all about soils, and we will have 4 lectures, mini lectures of this chapter, so here we go. All right, so the first thing that I really want you to know, and you will need to memorize this, you will need to know this, is a little quote that I learned when I was 14 years old, when I went to my first soil judging practice. And it was this: my ag teacher said, Allison, soils are different, soils are beautiful, and soils never change. And you're probably thinking exactly what I was thinking. What? And so we're going to talk a little bit more about this in class this week, but this is so true. Even if you don't know much about soils, this is extremely true. They are different. They are beautiful because they grow things and they never change. Soil never changes. And so that's kind of what we're going to go through today. And this lecture is going to be very broad, but we're going to kind of break it down into smaller pieces in class this week. Okay, so here's our outline. We're going to look at 5 major things. We'll look at the profile of soils. We're going to look at how soils are combined and what the components of those soils are. We'll look at properties, nutritional needs, and degradation of soils. All right, so some key concepts that will go along with all of those in the previous slide. So soil is an essential resource. So what we have now is what we have, and we will never be able to go buy new soil. So that's not a thing. What we have is what we have, and we need to be able to maintain it and sustain it for future generations, like we talked about last chapter. So soil is a mixture between 4 different things. We have organic matter, which you'll hear me talk about a lot, liquids, gases, and minerals. So that is what a soil is a mixture of. And then on top of that, there are different properties that allow plant growth, like texture, the chemistry of the soil. So if it's alkaline, if it's acidic, what kind of nutrients are in that soil, and then the structure of that soil. So is it a platy structure? Is it a blocky structure? And we'll talk more about that as well. Also, really important to know that the soil supplies the nutrients for plants, and if we don't have that, we wouldn't be able to grow plants within a soil. There are some really awesome there's some awesome science going on in the world of agriculture, like hydroponics, and that's allowing us to actually grow food in just water and supplying those nutrients in just water. But to maintain what we're growing now, it's really important to be able to know that there are a lot of nutrients in the soil and upkeep that soil as well. We have different types of fertilizers, which we'll talk about. We'll look at the difference between organic and inorganic, and we'll look a lot more of that in class this week. And soil degradation, so how erosion is really intercepted and is kind of gets a really bad name within agriculture, ag erosion, and we'll look at that as well. Okay, so what is soil? Make sure you know this first definition, this first bullet. It's just defined as a biochemically weathered. Okay, so biochemically meaning we have to use things that are on this earth, chemicals. It's weathered, and the utmost portion of the Earth's surface. And I'm going to show you a picture of the Earth, kind of a cross section of it here in just a second. Obviously, it provides us with a lot of different things, like gives the plant's roots somewhere to grow and then absorb the nutrients like we talked about, the chemical nutrients, the oxygen, and water as well. There are ecosystems like we talked about last week, and we have 2 different types of ecosystems. We have an ecosystem that's natural and it's not really messed with by humans, and then we have an agroecosystem that is farmed or ranched or maintained by humans. Also has a huge ability to supply a lot of nutrients if it's taken care of correctly. So this is just an example of what our soil can provide us. So here you have 3 different types of plants here. We have a tree, we have another plant in the middle there, and then a corn plant on the right hand side. So if you look down there, I want you to see that rock. So we can definitely tell if there is a tree growing, that root system is going to be huge, right? So we know that that rock is going to be pretty far down. But if you go to a corn plant, that rock is is a little bit more up. So it could be 6 foot down under the soil, or maybe 10 foot down under the soil, depending on what type of crop it is. So different types of plants, trees, shrubs will grow where they're not going to hit rock. So we still obviously have a little bit more room under that tree than those other two plants as well. But if you have a tap root, so that middle plant there has a tap root, and if it's going to be able to go as far down as it can, it's going to be able to grow there. So just provides a median for plant growth in soils. So this is that cross section of the earth that I was telling you about. So you can see that it has a couple different parts here. We have the atmosphere, then we have the soil, then we have the continental crust. And if we were to look at this from a bird's eye view, we would see that our soil is a very, very small part of our earth. So the crust obviously can't grow a lot there. That's really just parent material. That's really just rock. And then you have mantle, and then you have the core. So looking at this, it's even more crucial to maintain that soil that we have today. So soil profile, I'm going to show you a picture in just a second of what that looks like, but this is just that vertical section that we see extending through the surface to an unweathered rock. So if you've ever judged soil, you've seen a soil profile. You've seen different layers, different colors within that soil profile, and we'll talk a lot more about that this week in class. And this is really important too, because this is where we can tell where the topsoil starts and where the subsoil begins, which is really important in crop production and ranching. And it enables us to hear the story of that soil and what it needs, what it's lacking, what it has, what kind of nutrients it has enough of. And so those horizons, we call those horizons, those layers or horizons of that profile are very, very important to know what the difference is. So we'll look at that as well. So here is that profile, that soil profile. So again, if I were just to go into a pasture and dig a hole and maybe, like a 6-foot hole, I would see something like this most likely. So I would see that O layer, what we call the organic layer, the humus. Then we have the A layer, and that's what we would call the topsoil. So that's where all of those nutrients and salt are leaching into. That's that layer from the humus, or the organic matter on the top. Then the B layer is the subsoil. That's where a lot of the salt sits. Then we have the C layer, which has mostly weathered bedrock, and then parent material or bedrock below there, and that will just start to seep up as time goes on. All right, so soil orders. This is really important because this obviously tells the story of how long our soils have been on this earth, and this is just a way for us to classify what we have, what kind of soils we have on this earth. So there are 12 that apply to us in the United States. Mollisols are the most important part, or the most important soils within agriculture production in the United States. With a mollisol order, we can really grow a lot of great yields, we can grow a lot of great crops, and that's really important for the way we farm. And so that soil order is my favorite, and obviously agriculture's favorite as well. So here are two different orders. I talked to you about the mollisol, which is on the right-hand side, and then the alpha sol is on the left-hand side. So we find alpha sols in more of a humid climate, not really extreme from season to season. And then a mollisol is like a grassland climate that we have in the United States. So very semi-arid. It's not humid all the time, but it is humid sometimes. So you can definitely tell the differences there between the two. Alpha sol soils, they grow more deciduous trees, more vegetation than a mollisol would. And there's a difference there between the color. You can definitely see differences between color. You can see differences between different parent material coming up through those different layers. You can see the difference in texture. So we have more of a clayey mollisol on the right-hand side, and more of a silt loam on the left-hand side that intermixes with that humus and those colors as well. But If you look at the top there, there's more forest litter, there's more things to decompose within that soil, not so much on the right hand side. So that's just a comparison for you to show you the different types of orders that we have.